let here two lines L1 of x comma y is equal to 0, comma L2 second line L2 of x comma y is equal to 0. The two lines let L1 of x comma y equal to 0, L2 of x comma y equal to 0 be two lines, and ax1 y1 comma bx2 y2 be 2 points. Then number 1, if L1 of x1 y1 into L1 of x2 y2, L1 of x1 y1 into L1 of x2 y2 is greater than 0, and L2 of x1 y1 into L2 of x2 y2 is greater than 0. So L2 of x2 y2 is greater than 0. Then the 2 points lie in the same angle formed by L1 and L2. In the same angle formed by L1 and L2. This is the first point. Next, second one is if L1 of x1 y1 into L1 of x2 y2 less than 0, and L2 of x1 y1 to L2 of x2 y2 is less than 0. Both are less than 0. Then the points A and B, contained in the vertical opposite angles. Vertically opposite angles. This is the second one. Third one is L1 of x1 y1 into L1 of x2 y2 is greater than 0, and L2 of x1 y1 into L2 of x2 y2 is less than 0, or vice versa. Vice versa means, so this L1 of x1 and L2 of x2 y2 less than 0, L2 of x1 and L2 of x2 y2 is greater than 0. Means one is positive, one is negative. In first one, both the products positive. L1 of x1 and L1 of x2 y2 positive, L2 of x1 and L2 of x2 y2 positive. In second one, L1 of x1 y1, L2 of x2 y2 negative, L2 of x1 and L2 of x2 y2 negative, both negative. In third one, L1 of x1 and L2 of x2 y2, L1 of x1 and L1 of x2 y2 positive, L2 of x1 and L2 of x2 y2 is negative, vice versa. That is, this is positive, negative, this one is positive. That is also valid. That's why I have written vice versa. Now we will prove it. We will see the reason. For first one, explanation for first one. So explanation first one. So first one is what? If see the first one, the two lines and 2 points are given. L1 of x1 and L2 of x2 y2 is positive, L2 of x1 and L2 of x2 y2 is positive, then the points lie in the same angle formed by L1 and L2. Suppose this is line L1. So this is the line L1 and this is the line L2. In first one, so this is L1, this is L2. In this one, first one is what? That both the points lies in the same angle formed by. The same angle formed by the line means suppose this in this region. So in this region, if the points are like this, means not only here, the point may lie here or here or here or here. Any of the four regions, same angle region. So this one. If the situation is like this, then the condition is what? L1 of x1 and L1 of x2 y2 positive, L1 of x1, L2 of x1 and L2 of x2 y2 is positive, because with respect to L1, both the points lie same side of the line or not? Yes or no? Yes. L1 of A into same side into positive. Already we have seen last result. L1 of A, L1 of B. A is what? X1 y1, x2 y2. X1 y1. Here B is x2 y2. Already we have seen if the 2 points lie same side of the line, then here L1 of x1 y1 into L1 of x2 y2 is what? Positive. Already we proved this. Now with respect to second line also, these are same side. Therefore, this is L1 of L2 of x1 y1 and L2 of x2 y2 is positive. So with respect to this line, same side. With respect to this line also same side. Means these 2 points lies in the same angle formed by the L1 and L2. This is the proof or explanation. Clear? First one?
Yes, sir.
Now second one. Second one, explanation for second one. See, in second one, if L1 of x1 and L2 of x2 negative and L2 of x1 and L2 of x2, then the points A and B contained in the vertically opposite angles. So vertically opposite angles means, see, now, so here the situation is different. Here vertically opposite angles. Vertically opposite angle means suppose A x1 y1 lies here. Vertical opposite angle means B x2 y2. So A may lie here also, AB or AB like this. Okay. So I have taken this example. Now this situation, this case otherwise. Okay, vertical opposite angles. Now see, now with respect to L1, so you forget about L2. Just you see L1. With respect to L1, A x1 y1, B x2 y2 are opposite sides or not? That's why.
Yes, sir.
Yes, L1 of x1 y1 into L1 of x2 y2 is negative with respect to L1. Now you forget about L1. Now with respect to L2, you see both are opposite sides. That's why L2 of x1 y1 into L2 of x2 y2 is also negative. This is the reason. For second one. Next, third one is, see, if third one is this product is positive and the second product is negative, or first product is negative, second product is positive, vice versa. Then what is the condition then? Okay, then I have not written this. Less than 0, I will write. Then vice versa. Then the points A and B, and the points A and B must be contained in the adjacent angles. In the adjacent angles. So this is the third case. So same. So here the situation will be like this. Adjacent angles. Adjacent angles means suppose A is somewhere over here. Adjacent angles means B is in this region, like this. Suppose A is here, B is here, or A is here, B will be here. So in this situation, now the explanation for this one is, see, now with respect to L1, you see, with respect to L1, A x1 y1, B x2 y2 are what? Opposite sides. Okay, na?
Yes, sir.
That's why with respect to L1, if you see L1 of x1 y1 into L1 of x2 y2, opposite side, that's why less than 0. Okay. Now with respect to L2, if you see, both are same side. Okay, both are same side. That's why both are same side means L2 of x1 y1, into L2 of x2 y2 must be positive. So one is positive, another one is negative. Vice versa also true. How? If the diagram is like this, suppose the diagram is like this, suppose the points are, suppose vertical opposite, suppose this point A x1 y1 is here, so B x2 y2 is here. These are also opposite, vertically adjacent angles. These are no, here adjacent regions or angles. Now in this situation, now with respect to L1, if you see, both are same side. That's why L1 of x1 y1 into L1 of x2 y2 is positive. But with respect to L2, both are opposites. Therefore, with respect to L2 of x1 y1 into of L2 of x2 y2 is negative. These are both the cases. L1 x1 y1, L1 x2 y2 is negative. Here L1 x1 y1, L1 x2 y2 is positive. Here L2 x1 y1, L2 x2 y2 is positive. L2 x1, L2 x2 y2 is negative. Clear? Proof?